So I want to sketch the given functions and find the area of an enclosed region. So there's steps in how to solve this type of problem. And so step number one, you draw a picture. Okay? Step number one in this type of problem, I expect you to draw a picture. Step number two, make an arbitrary rectangle in your picture so that you know where your area is. So like for this example here, we drew the function f and g, and then we made an arbitrary rectangle so that we knew what we were integrating with respect to, dx here, okay? Number three, set up the integral, all right? So I set up the integral. How do I do that? I try to figure out, okay, what's the height of the rectangle? So I do top minus bottom. And then what is the width of the rectangle? Well, my width here is my delta x, my change in x. That tells me what to integrate with respect to. So I set up my integral. I find the area of an arbitrary rectangle. And then the only thing left I got to do is I got to figure out where am I integrating from. I'm integrating from a to b. So I start at x equal to a and I end at x equal to b. Okay? So it's important to understand those steps when you're setting up your integral. Number four, and the last one, after you get the picture drawn, the arbitrary rectangle that helps you set up the integral, then you compute the integral. So I figure out what the answer is to that definite integral there. And that's all there is to it. So let's do a problem where we illustrate those four key steps in finding the area of the enclosed region. So I've got two functions, 2 minus x squared and x. So first thing I want to do, number one, draw the picture. So I'm going to draw a graph, okay? And so I want to graph, parabola first. So this is a parabola at 2 minus x squared. The x squared tells me it's a parabola. I know this is a sad parabola because the coefficient in front is negative, so we're frowning. I have a vertical shift up 2, so my vertex is up here at 0, 2. So I put those dots there to kind of guide me on how a parabola works. In general, when I think about a parabola, I think about x squared, right? So x squared at 0, it gets you 0. At 1, it gets you 1. At 2, it gets you 4. At 3, it gets you 9, right? So when I think about it, I kind of plot it like this in my head. I go over 1, up 1. I go over another one, I go up 1, 2, 3 from there, right? So to get, when I plug in a 2, I output a 4, right? So that kind of gets me my overall general pattern, and then I can repeat it on the other side. So if there's a negative coefficient, all I do is I just literally flip it down this way. So over 1, down 1, over 1, down 3, and I kind of go, and I've got my pattern going, okay? So that's kind of how I think about it in general. That's more of a college algebra topic. You can go to college algebra, how to plot a quadratic, a parabola, and I'll go into detail on how to do that. To plot a line is pretty simple. Y equals mx plus b. So here I have g of x, which is my y, equals 1x plus 0, right? So the y-intercept is your b, so my y-intercept is 0. And the slope is 1, so that means I rise 1, run 1. So every time I go up 1, I go over 1. Up 1, over 1, up 1, over 1, up 1, over 1. And then all I need is 2 dots to make a line, okay? So once I have my picture drawn, now I kind of have an idea of where the enclosed area is. Okay, it's that shaded region right there. Okay, I need to make an arbitrary rectangle at this point. So to do that, I need to know what my top function is and what my bottom function is. So once I know my top function and I know my bottom function, then I can figure out what top minus bottom is with my arbitrary rectangle. Looking at this, which way is it skinny? It's skinny the dx way here. So in the x, it looks like we're going to be making x slices as we go around, as we go through here. Those are going to be x slices going on. If my rectangle was like this here, those would be dy slices, it's changing. The y value is changing as I go up and down, okay? And so you can see here that's clearly x values that are changing. So I have my top function is the parabola. The bottom function is the line. So f minus g is going on here, and I got my delta x. So the top minus the bottom here. So we're trying to set up the integral, right? To set up the integral, what do I need? I need my top function minus my bottom function. Okay? So don't just get all caught up on the f minus g part. I could have switched these f and g around. It's always the top minus the bottom. If you do bottom minus top, you're going to get the negative of it. Okay? When you're looking for distance, you do the big one minus the less big one. Okay? So the parabola, the top, the f of x goes here. The bottom is the x, and that goes there. So top minus bottom simplified here. That just gets me 2 minus x squared minus x. Okay? Now I want to figure out that I've got this, and I know it's with respect to x. I'm halfway there. I've got 2 minus x squared minus x dx. The only thing that I have left is I've got to figure out what a and b are. Well, remember, a and b tell you where you start and where you stop. Okay, so it tells you where to stop and start and stop summing your rectangles. So where do I want to start summing my rectangles, and where do I want to stop summing my rectangles? Well, I'll tell you right here. I want to start summing my rectangles there, and I want to sum them up all the way to right here. Okay, and that's where I'll stop. All right, so that means I need to figure out where the graph intersects here and where the graph intersects here. How do I figure out where f and g are equal to each other? That's the two places that they're equal to each other, right? I set the two functions equal to each other, and I'll figure out those x values. So I'm going to set those two equal to each other. So I have f of x, which is 2 minus x squared, equals g of x, which is x. And so I need to solve this equation here. So what I'm going to do is I'm going to move the x squared to the other side, and I'm going to move the 2 to the other side. So to do that, the opposite of negative x squared is plus x squared, and the opposite of 2 is negative 2. So I'm just going to move that by subtracting 2 and adding x squared to both sides. So I have 0 equals this thing right here. Okay? I can factor this. It's a trinomial. Once again, you can go back to a college algebra video to see how to factor trinomials if you're having trouble. I want something that multiplies to negative 2 and adds to 1. It's an understood 1 coefficient there. So if I multiply 2 times negative 1, that multiplies to negative 2 and it adds to 1. So 2 and a negative 1 right there. So I need to solve for x. This is set equal to 0. So that means I do x minus 1 equals 0. So x is equal to 1. And then here I do x plus 2 equal to 0, and so x is equal to negative 2. Okay? So those will pop up in just a second. So that's my, I went a little too far. Okay, so, excuse me. So whenever I got this x equal to 1 here, I see that I have a 1 intersection here, and then the x equal to 2 here gets me, or negative 2 there gets that negative 2 that I was looking for there. Okay? So this tells me what my b is, and this tells me what my a is. How do I know which is which? Look, we start with the lower limit, and we sum rectangles all the way till we get to the upper limit. So we start with the low number, negative 2, and we stop with the higher number, x equal to 1. So my integral goes from a to b, f of x dx. We know that my f of x here is the top minus the bottom, right? And the top minus the bottom happens to be this equation right here, f minus g. And so that's the height of the rectangle. This is the width of the rectangle. and then I sum up all the rectangles from -2 to 1, right there. When I integrate this function here, the integral of 2 is 2x. The integral of -x squared, I have -x raised to the add 1 to the exponent, divide by that exponent. And then this is understood to have an exponent of 1, so when I add 1 to it, I get 2, divide by it. I get that there. And so I want to evaluate this from from -2 to 1. So from -2 to 1 is where I evaluate it. So I'm going to use the fundamental theorem of calculus, part 2. And so I have f of b, which is f of 1 minus f of -2. Okay, f of b minus f of a. I always do the top one first, then I do subtract the bottom one. But the antiderivative evaluated at 1 gets me, if I plug a 1 in for x, I get 2 times 1 minus 1 cubed over 3 minus 1 squared over 2. So that's 2 minus a third minus a half, which is right there. And then I have plug in a -2. Everywhere I see an x, I'm going to get this right here. And so simplifying this, you get 7/8. Okay, so you can type it in your calculator. I don't care. Show you how to type it in your calculator. Just make sure you know what's going on. I always want to make sure I explain it as best as I can. So if I did this parentheses 2 minus 1/3, and then minus 1/2, and then minus parentheses -4 plus 8 divided by 3 minus 2 close parentheses, enter, I get 4.5 if you, what did I do? Oh, I didn't write it out all the way yet. That's okay. All right, and so then math frac gets me 9/2. So what I did was I calculated the 7/6 is the first part there. So I'm glad I walked through that. So I got a little ahead of myself. So this is 7/6, and then this part here is a -10/3, but negative and a negative make a positive. And so this is going to get you 27/6, which reduces to 9/2, just like what your calculator said, 9/2 there. Okay? Let's do one more. Make sure we got it. So we've got another parabola, and then this time my line is a negative slope. Okay? So with this problem, I've got a parabola, and it's shifted up 2 units, but this time there's a +1 coefficient, so we're a happy parabola, shifted up 2 units. I'm going to count 2 blocks at a time for each one, that way, because I'm pretty close here, this would be my vertical lines. These would be the vertical lines, x equals 0, x equals 1, and that way I'll have enough room so you can actually see what's going on here. So first thing you do, always draw the picture. Once you draw the picture, so then I need to make my vertical lines at x equals 0 and x equal to 1. Then I will know the shaded region. So the shaded region here, the enclosed region, arbitrary rectangle, that's step 2, make your arbitrary rectangle. In terms of dx, we're going to do all of ours for dx. When you take calculus 2, we'll talk more about how to figure out the area using dy rectangles. So if you're looking forward to that, I mean, that's great. Cal 2 is great class. It's probably my favorite class to teach. So definitely looking forward to that if you're going to join in on that. I hope that you do. I really do. Pretty fun class. And so top minus bottom. I know that was a pretty sad pitch, right? But you know, it's cool. It's cool. All right. So the top function here is y equals x squared plus 2. Okay. The bottom function here is that negative x. So I have top minus bottom here, but the negative and a negative end up making a positive here. So that's my inside top minus bottom going on here. Okay. So here it wasn't labeled f and g. So just so you know, it's not always going to be the case that the parabola is on top. It just so happened to be for these two examples that we had. How do I find the limits of integration? Well, the limits of integration are a little easier for this particular problem because whenever I make my rectangles, okay, so when I make the rectangles, they start at 0, and then I add all the rectangles from there to x equal to 1. Okay? So x equals 0 to x equal 1 are the limits of integration. So the difference between the first problem A and the second problem B, the limits of integration were basically given to us in this one. To find the limits of integration of the first one, I had to figure out where the intersection was, okay? Where the shaded region started and stopped was defined by where the f and g crossed each other. The thing about this graph is f and g, they never touch. So unless you know these vertical lines here, then there's no way that you would be able to shade all of that in. There'd be an infinite amount of area there. No bueno. Okay? So I'm going to plug in 0, start summing my rectangles from 0, and I'm going to sum my rectangles from 0 up to 1. Okay? And so it's going to be what? It's going to be this function minus that function, which gets you this thing right here. So I plug that in. This is the height. This is the base. It's a delta x change. It's changing with x. So I add the areas of all these rectangles starting at 1 and add them up till I get to, starting at 0 and then adding them up till I get to 1. Okay? So to do this, I integrate x squared. Whenever I integrate x squared, I add 1 to the exponent, divide by it. Integrate 2, I get 2x. Integrate x, I add 1 to the exponent, I get 2, divide by 2. And I evaluate it from 0 to 1. So f of 1 minus f of 0. So that means I'm going to plug a 1 in everywhere I see an x. And so that's going to produce 1/3 plus 2 plus 1/2 minus, and I plug a 0 in everywhere I see an x. All these terms kind of go away, okay? So it amounts to adding 1/3, 1/2, and 2 together, and whenever I do that, I get 17/6. So hopefully you can see kind of how, whenever I zoom out here, everything all in one